then the lax raised SI unit of absolute permittivity. Force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Force is in Newton. Is it not? This doesn't have any unit. Therefore, 1 by epsilon naught you put like this. Coulomb, this is also Coulomb, meter square. Then you bring this down, you bring down. Therefore, I am taking to the numerator. This is equal to Coulomb square, Newton, meter square or epsilon naught per Newton, Coulomb square per Newton per meter square. Therefore, epsilon naught you express in terms of force, that is per Newton per meter square Coulomb square, or Coulomb square per Newton meter square, per meter square, right? Per meter square, this epsilon naught. They may ask you for 1 mark. See here what? Suppose they ask you what is the unit of relative permittivity. Relative permittivity is what? The ratio of force between the two charges at air and force between the same charges at the same distance in medium. Newton cancel. Therefore, it has no unit. You write no unit. For that 1 mark. Or epsilon medium by epsilon naught. Same unit get cancelled. Therefore, Newton get cancel. For unit of relative permittivity is what? No unit. Now there was a question, is Coulomb's law is conservative or non-conservative? The answer is what? Conservative. Coulomb's law is what? It's conservative. What conservative force? The forces are conservative. See, remember, there are two charges, right? Two identical charge. There is a force in air, right? Force is air. The force of repulsion is more. Now, if I introduce some dielectric medium, epsilon r. For epsilon r is always greater than 1. Force in air, force in medium is equal to epsilon r, which is greater than 1. Therefore, force in air is greater than force in medium. In other words, when you introduce any other dielectric medium, the force reduces. The force in medium is less than force in air. Now, if you keep a metal, for metal, it is infinity. In that case, what? Force is inversely proportional to epsilon, medium. For the medium, it is infinity. Therefore, force will be 0. Nothing will happen if you keep a metal in between. See, another simple question. Suppose Q1 is equal to 3 Coulomb. Q2 is equal to 7 Coulomb. Which charge will have more force? Either 3 or 7. Both will exert equal force. Because force is, this is action, reaction pair. Got it? See, what is the action? This is A and B. What is the action? Force on B due to A is same as, this is an action, means the equal and opposite action. Force on A due to B. They are equal and opposite reaction forces. Therefore, force remains same in both the charges. Right? This is called action, reaction, pairs, both are. Remember, electric field at the point is equal to force per unit charge. There is electric field at a point is equal to force per unit charge. Right? This is Newton per Coulomb. See, expression for the field, electric field at a point due to a point charge. Consider a point charge Q at A. Right? It creates an electric field around it. Right? Let P is some point which is at a distance of R, where I keep a test charge at P. Now the test charge would experience a force of repulsion, right? Therefore, consider a point charge plus Q kept at A. Let P be a point where a test charge Q naught is kept. The test charge Q naught experience a force F. The force is given by 1 by 4 pi epsilon naught Q and Q naught by R square. Therefore, force per unit charge, this is what? Force per unit test charge is equal to 1 by 4 pi epsilon naught Q by R square. According to the definition, this is same electric intensity at P is equal to is force per unit charge. Force per unit charge. Therefore, electric intensity at the point is equal to 1 by 4 pi epsilon naught Q by R square, and what? Unit is Newton per Coulomb, or volt per meter also you can write it, but this is an expression. For this, they will ask you for 3 marks. Right? Writing the diagram and description 1 mark, and writing this expression up to this 1 mark. Then the definition of electric field and this with the unit 1 mark. Okay. See, if they are asking in vector form, 1 by 4 pi epsilon naught Q by R square and R cap. What is electric dipole? Suppose the two charges, one is minus Q, another is plus Q, separated by a distance, say A, right? Or 2L, anything, 2L, where this is L, this is also L. Therefore, electric dipole is what? A pair of equal and opposite charges separated by A small distance, a small distance. What is that? 2L or 2A, whatever it is. This is A, this is A. Distance is called electric dipole. Now, what is the direction of the vector here? Electric dipole is a vector quantity. It is measured by electric dipole is a vector quantity. Charge, magnitude of the charge, and distance between the charges. It's a vector quantity. Therefore, this is a vector quantity. Now, which is the direction? Coulomb meter. Coulomb meter is the unit. Which is the direction? From negative to positive. Right? This is called electrical dipole. From negative charge to positive charge direction. That means direction of electrical dipole is equal to from A to B, like A to B here. Therefore, the vector is this. If I write like this, dipole moment, this is minus, this is plus, minus Q and plus Q. Which direction? Electric dipole. From negative to positive. Electric dipole moment is equal to, you can write L and L, 2L. Charge and 2L. Coulomb meter is the unit. They may ask you for 1 mark. And which is the direction of the vector? From Q to plus minus Q to plus Q. You understood?